Example number 8. We now discuss the next one is if pressure P is given by P is equal to A minus L square by BT, where L is length, T is time, and A, B are constants. Find out the dimensional formula for B. The dimensional formula for B, so according to principle of homogeneity, the value of A is equal to value of L square. A is equal to L square, where L is length, so L power 2. And now we find out the value of B. So for B we can write from equation is P B T is equal to dimension of A. Okay, so if the value of B, can write it as A upon P T, where P is pressure and T is time. A, we've already find out the value of A, L square. So write it here, L2. P is pressure. We already found out the value of pressure. So we write here the same value as it is, M L minus 1, T minus 2. And T having the value, time having the value of T. So after solving it, we find out the value M minus 1, L3, T1. This is the value of B. Thank you. 9 number example. Find out the dimensional formula of gravitational constant G, coefficient of viscosity neta, and the specific heat capacity is S. The value of gravitational constant, here we find out the value for this. As we know that from Newton's law of gravitation, F is equal to G m1 m2 upon r square. Here the value of G is equal to F r square upon m1 into m2. Here we know that the r square is in the form of length, m and m, these are the masses of bodies, and F is the force. We have all these values in the dimensional form, and F value is M L T minus 2, force having this the dimensional formula, and r square is in the form of length. Here m1 and m2 are masses. We can write it as m square as well, and the value of G is m minus 1 L3 T minus 2. The next one is viscosity of coefficient of viscosity. We can find out like the resistive force. The resistive force on a spherical body of radius r and moving with the velocity v in the fluid of coefficient of viscosity neta is given by, we can write it, the formula is F is equal to 6 pi neta r v. So the value of neta, here we find out the value of neta, that is F upon 6 pi r v. Here 6 pi are the constants, so in the dimensional formula they do not have any formula for dimensions, and we can write out we find out the F upon r into v. So the value of F is M L T minus 2, as we already find out this value in the first video, and M L2 T minus 2, and r is the length form, v is velocity, so Lt minus 1. After solving it, M L minus 1 T minus 1, we find out this value, because this L is cut by this, and here T minus 2. If you are you find the difficulty, I help to I will solve this again. ml T minus 2, and this is the value of L into L T minus 1. So this T1 minus 1 is when going to upper side, then it gives the value plus 1. So here we find out the T minus 1. L to L cut L is 1, and if it goes to up, and this having the value of minus 1. This is the value of NEET. The third one is see, we find out the value of specific heat capacity. The formula for this is Q is equal to ms delta T, where Q is the heat energy, m is mass, this is specific heat capacity, and this is the delta T is change in temperature. So we find out the S value. So S is equal to Q upon m delta T. As Q is the heat energy, and so the dimension formula of here is m L2 T minus 2, because it is also an energy form, and here mass is m, and if we talk about temperature, it gives the value of K, that is Kelvin. So the formula we get m naught L2 T minus 2 K minus 1. This is a formula, dimension formula for the specific heat capacity.